So you need to have a flashcard that looks like this. So on the test, there will probably be at least one, maybe two questions that will check to see if you understand the mean value theorem. So you need a flashcard that has this information on it. This is the mean value theorem. I write on one side of the card, I wrote this quote because it came from a problem and it helps remind me of when I'm supposed to use the mean value theorem. It says there exists a C between 3 and 7. This is just from some problem. So C is some x-coordinate. So there's an x-coordinate between 3 and 7 such that the tangent slope of f somewhere is going to equal 0. Like that's a big hint if they want me to use the mean value theorem. Because the mean value theorem is trying to get you to remember that if a function is continuous and differentiable, just read the name for me. Tomorrow, raise your hand. Thank you. So the mean value theorem says if f is continuous and differentiable, then somewhere on the curve of f, there will be a tangent slope that is the same as the secant slope. This is the symbol that means the tangent slope of f at some point called c. This is an equation for calculating the secant slope from point A to point B on some curve. That's the mean value theorem. And we want to talk more about the mean value theorem to make sure you understand it. Give a second for everybody to make the card here. Just wait until the writing stops.
So are you trying to find the point or the tangent slope?
That part, 2 points for Harrison. That part will vary from problem to problem because they like to test you in all different ways. In the problem you're asking about, they're specifically saying, hey, go find this magic x-coordinate called c, where the tangent slope will have the same value as the secant slope.
So if it just says find c, then it's going to be the x-coordinate. If it says find the slope of c, then you're going to find the slope.
Yeah, I've seen that. It's a good question, Jacob. I have seen an AP problem where, I can't give you exactly the details because I'm going from memory, but I'm pretty sure the problem was something like this. Like somehow they describe a situation where they say, oh, this particular function satisfies the mean value theorem at c equal 6, you know. And then they ask you to figure out what's f prime of c. They want you to find that slope somehow. And what you had to do was, in the problem, they had given information that would allow you to find this slope. Well, if I know this slope is 10, then I know f prime of c has to be 10 if c is the place where the mean value theorem is satisfied. I've seen it happen that way. 2 points. Please.
Can you go back to the slide?
So if you're solving for the slope, then you can just find the secant slope and you're set. But we're trying to find the point, so there's an extra step, right?
I think we're good. Okay, looking back at the problem. Okay, Okay, everybody look over here. Everybody looking at me. Okay, quick example of what I'm trying to get you to do in this class. I had a student stop by at lunch. A few people were here. Her name is Autumn Kelsch. She was in my class about 4 years ago. Okay, and she was super excited to tell me that she is on track to go to medical school. Okay, so it's what I've been trying to tell all of you all year. I don't care at all if you ever use calculus again. Like, Autumn won't use calculus as a doctor, okay? But what she will use is like the habits and the way of thinking that she developed in this class. She specifically mentioned that getting through this class has helped her get through what I've been told. I've not taken this class, organic chemistry in college, very high on the most difficult class you can take. She's making it through because she learned in this class how to think in a logical way, and she learned how to like discipline herself to make sense of things. Autumn was extremely good at sitting in the room and never being content with, well, I guess I can do that. She's like, no, I don't understand. She would just ask and ask and ask. That's all you have to do here is just keep making sense of it. You cannot succeed in this class or in any other really meaningful college class by just doing what the teacher does. You have to understand what's happening, so just keep asking. Okay, another thing I want you to learn is this. For AP questions, please keep telling yourself, I don't have to know step 1 through 4. It's not like your other math class where like you look at a problem and go, I've done that one 10 times, so here's how you do it. Here, the problems always look a little new. So don't worry about steps 1 through 4. All you have to do is find one flashcard, think of the flashcard, and then just do one step. So we've talked about the flashcard, it's the mean value theorem. So raise your hand, what's one thing I can do? You don't have to know every step, just one thing. Like based on the mean value theorem flashcard, what's one thing that would seem logical to do in this problem? That voice is very exciting.
Make sure f is continuous and differential.
2 points for that. That one's a little tough because they didn't say that it was, but they implied it. Because they said C is a number that will satisfy the conclusion of the mean value theorem. So they're saying there is a value that will satisfy the mean value theorem. And then they don't give any answer, which would be like there is no C. So they're implying that the function is continuous and differential. It's a good comment.
When we find secant slope?
Finding the secant slope makes sense to me because the slope I'm concerned about in the mean value theorem problem is the secant slope. It's like the main thing. 2 points.
Do you not have to find the y values for the two x coordinates that you already have first?
So I like the sequence here. Look. Okay, the thinking here is very, very good. It's exactly what you have to do in this class to be successful on the AP test. You thought of the flashcard. The flashcard led you to think, hey, I need to find the secant slope. Once you write this down, then you have the thought that Matthew's having, which is, well, I can't really find the secant slope if all I have are the x coordinates. I need the y coordinates. So he remembers I have a formula here that can be used to find any xy pair. So let's do that. It's like, I told you this joke, but it feels like going through puberty in reverse. Okay. Yeah, I want to pay the whole room, so no one speak out. Just raise your hand. Oh, thank you. Okay. The other thing you have to do in this class is you can't just do the work. You have to be thinking as you're doing the work. The way I think of that is you do a little step, and then you kind of draw back and look at the big picture again. Okay, I just discovered something extremely helpful by doing these computations. Who knows what I'm thinking? And These computations have revealed something very, very helpful. What have the computations revealed? You got to think big picture. You know, think, what is the whole problem talking about? Why would this calculation be meaningful to me? You can't just do the calculations. You got to make sense of them. So say to you.
You discover that the secant slope is 0.
The y coordinate at one end is 0. The y coordinate at the other end is still 0. So secant slope is change in y divided by change in x.
Wouldn't that be undefined?
So the change in y is 0. The change in x is 2. It's easy to get mixed up.
Okay.
Now this is 0. The other way around is undefined. So, how many knew this? 2 points. Okay. We proceed.
So that means just like a flat line.
Yes, so I have this function, I don't really know what it looks like, so I just gotta do my stupid drawing that I always do.
Is it 0 over 2 because the change in x is, in this situation, b minus a, which is 2 minus a, right?
So it's simpler than what you're saying it. All you have to do is answer this question. From this x to this x, how much did the x change? Perfect, so that's 2. And then from this y to this y, 0. That's 20. So Harrison's right. Do they want me to clarify anything? Please.
If it's a flat line, couldn't any one of those points match it? Except for 0 and 2, because they're the beginning and endings.
I'm not sure what you mean by any of those points.
Like
Sorry.
1/2, 1 or 4/3 could make. If it's a straight line and their slope's all 0. Right?
It's a good question. 2 points for Harrison. Everybody look up. Come on. Let's focus. Okay, what Harrison is doing is he's mixing, like you're mixing up the meaning of things. You're losing track of the meaning. Hands up if you know what these represent. What are these representing? Let's go, Shem.
Isn't it the x values on the curve?
Yeah, these are x coordinates.
Yeah.
Yeah, these aren't slopes. These aren't lines. They're just points. They're just x values.
Now, are those x values that make up part of the secant slope?
No, these are just x coordinates.
They're not.
These are just some x coordinates. Like we have some curve. These are just different x coordinates on the curve. That's all they are.
And do we know that that curve is a parabola like that?
No. Maybe it's this. All I know is that from one point to the other, the secant slope is 0. That's all I know. How many knew these were x coordinates? 0.2%. Please check.
Isn't, I think what's being confused is that you're trying to find which of those points has a tangent slope of 0. So you can't just like plug in those as an x coordinate. So since it's changing by 0, it's going to be 0.
Yeah, these are just points. They're just points. They don't tell you anything. 2 points for Jackie. Other questions?
So we find C by taking the derivative of the first f and plugging it in. What's that?
Okay. The thing you're practicing is, as much as possible, you want to make sure when you take a step, you have a reason for doing it. It's really bad in this class to just start doing stuff. Who knows what? You just get really confused. So Harrison is suggesting that we find f prime. There's a good reason for doing that. Who can tell me a reason why that makes sense? Like, why does finding the equation for f prime make sense? Why is that a good idea? It's not random at all. It's like, why is that a good idea, Tyler?
So we can like make a sign pattern. Well, not a sign pattern chart, but like so we can like find where the slope is equal to 0.
There you go. That's much better. Yeah, we don't need a sign pattern chart because we're not looking to see, like, the sign pattern chart. Look over here. We build a sign pattern chart at f prime so you can see like where f goes up and down. we don't care about that. But we do want this. Okay. Good.
Theoretically, couldn't you do that? Because when f goes from increasing to decreasing, the slope at that point is 0.
Not always. F could do this. Yeah, so 2 points. 2 points.
Mr. Smith,
Please.
help me understand why we find f prime. Is it so when I'm looking at this flashcard, it's telling me, the tangent slope equals the secant slope. Now, is it because f prime will give us the secant slopes of, or the tangent slopes of points on an f graph? That's why we find it.
That's perfect. That's exactly why we find it. Because we're looking for, so this points for everybody. Hands up, please. This formula is good for 2 different things. You have to know both ways that this formula can be useful. Who knows both ways this formula is useful? Talk to each other. I need more hands.
What's
Like,
finding it?
skipping that one. Hold on. It's a good comment. Listen. Hey, Harrison said finding f double prime, which is true. Just excluding that one. As is, this can be used 2 different ways. Hands up. What are the 2 ways you're going to use this over and over again? This isn't going to happen on this problem. It's going to happen on a whole bunch of problems. So what are the 2 ways this gets used?
So my logic on that was kind of
Because you want the tangent slope of one of those definitely tangent slope of f, and then
Okay, hands up. Who's got it? Hands up. Come on, who knows? Read.
Find the tangent slope of tangent line.
2 points, not quite, but you're okay. Like we use, okay, one thing you said is correct. I can plug into this formula. For example, I could plug into this formula x equal 1, and this formula would tell me the slope of f at x equal 1. It would tell me f prime of 1 is -1. That's telling me that on the graph of f, at an x-coordinate of 1, the slope of f at that point has a value of -1. That's one way we will use this formula over and over again. How many knew that? What's the other way you must know how to use this formula? You have to know both ways. It will happen repeatedly in this class, that you use the formula in 2 different ways. So what do you like?
It finds the point on f prime, the 1 point, sorry.
2 points for that one, for sure. There's still this other way that's people don't typically think of that you have to know. Like, what's the other way you're going to use this formula? Let's go, Amanda.
Can you plug in a number for all of us?
Keep talking.
Like, for how to explain it, like if you plugged in like a 0 for all of us, and that would help you get out what?
2 points, you're really close. Let me help you. Look, 2 points. Okay. Let's back up. I want to get out more extra credit. Look. In this equation, there's a big idea here that you are not understanding. It's not a calculus idea. It's something you were supposed to have learned like in 8th grade. But if you haven't, who cares? Let's just learn it now. Fair? Because you need it over and over again in this class. You have an equation here. Please raise your hand and tell me. How many symbols in this equation are... This is a bad question. I'll just tell you. In this equation, there's 2 symbols. X and f prime. X could be all kinds of different numbers. An infinite list. But so can f prime. Like, it can be all kinds of different values. So the way the formula is used is, in one instance, you know the x. You're like, I know that I'm interested in x equal 1. I want to go to x equal 1 and find the slope. So I did. But you can also do it the other way around. You can say, well, maybe we need to find out where on f is the tangent slope of f equal to 5? Like, I want to know at what x coordinate will the graph of f have a slope whose value is 5? Hands up if you know how to use this equation to answer this question. We've already used the equation to answer this question. At x equal 1, the slope is -1. How do we answer this question using this equation? Ethan?
Can we just plug 5 in for f prime?
Very good. So you would write f prime is 5, but that must equal 3 times some x squared minus 4x. And then you would have to use algebra or calculator to solve this. But that's the two ways that equation gets used. It does get used to find f double prime. It does get used, what was the other one somebody said? Yeah, it's to find the y coordinates on f prime, true. But the most often, you'll either be plugging in an x to find a slope on f, or you'll know the slope on f and you'll need to find the x. Anybody need more clarification on this? This is huge. Like, there is not a single concept in this class that is more used than that idea, right there.
Can you just say it one more time?
Huh? I think you just say it, Morgan, it'll stick better. Is that okay? So in this equation, what two symbols are considered variable, meaning they can have multiple values?
F prime and x.
Perfect. What is the symbol f prime representing?
The tangent slope of the graph of x. Or I mean f, sorry.
Of f, perfect. What is the x representing?
Of coordinate on yeah.
X coordinate on the graph of f. So this is an x coordinate on the graph of f. Could be on f prime as well. This is the tangent slope on the graph of f. So that means we can use the equation two different ways. If you are looking at the graph of f and you happen to need to know the slope right here, and the x coordinate is 3, well, it wouldn't be 3, but let's go like 1.5. How do you use the formula, Morgan, to find the slope right here?
You would plug in that x coordinate into the x's on the.
Perfect. Put that x coordinate into these x's, I do the computation, I find the slope.
Would it be, is it into the equation of the f prime?
F prime, I may have said that wrong. The other way around is, what if you're solving some problem and you find that, hey, I know the slope right here. I find that this tangent slope has a value of 7, but I'd like to know what x coordinate this is. How do I find this x coordinate?
You would plug in the tangent slope of 7 into f prime of x.
Perfect. So put the 7 here, and have to do algebra or calculator to find x. Is that your question?
Yeah.
3-point. Question? Awesome. So, in this particular problem, raise your hand and tell me what should we do now? Okay. Remember, you're practicing the following. You do some little stuff, but then you have to look at the whole problem again and say, okay, what am I supposed to be doing? So what do we do now? Come on. Dan.
So we found that the secant slope is 0, so I need to find what x coordinate matches has the tangent slope of 0.
That's perfect. You said it really well. Dan said, we know that for this function we're working with, as I said to Gil, we don't really know what the function looks like. But we do know that the function has a secant slope of 0, and this value of c that we're looking for is where the tangent slope will be 0. So we want to go find it. So just say it out loud, we're looking for an x coordinate or a slope. X coordinate. So we use this formula the way we just talked about. 2 points for Dan. How many knew he was going to say that? Point. So what do I write down? Yes, come on. What do I write?
0 equals 3 squared minus 4x.
There you go. How many knew that? Point. Questions? Okay. Success on the test is simply a matter of, you remember a flashcard, it reminds you to do something. Well, I'm hitting where I need another flashcard. It's right here. Quadratics. To solve a quadratic, you factor. In fact, to solve many equations on the AP test, you factor. So right here, I can't solve this the old-fashioned way. I can't get x alone. Don't try, you'll get the wrong answer. But you can factor, nothing.
Is there ever a time when you would use the quadratic formula to solve a quadratic instead of factoring it?
I've never seen it required on the AP test.
Okay.
Doesn't mean they won't, but I just haven't seen it required.
Couldn't you use the quadratic in this effect?
Oh, you can. There's nothing wrong with using it. Factoring to me is faster, but, you know. Okay, here's another property you've learned in a previous class. When you have one factor multiplied by another, one factor has to be 0. So just look at it. What value must x have to make this factor 0? 0. Now remember, if this x is 0, so is this one. But it doesn't matter. 0 here, 0 here. Who cares about this? The whole thing is 0. So one answer is x could be 0. Okay, 1 second. It is critical, come back there, Sid. It is critical that you not lose track of the meaning. So raise your hand and tell me, what is this saying? What does this mean? You can't just write down x equals 0 and say, I'm done, I found the answer. Who cares about the stupid answer? No, really. You don't care about the answer, you care that you understand what's going on. So what does this mean? Let's go, Jared.
The x coordinate is 0, and slope is 0.
Okay. I'm just going to adjust your same just a tiny bit because we got to get increasingly precise. At x equals 0, on the graph of f, the tangent slope is 0. How do you do that? Point it to project. But there's another value of x which will also make this equal 0. What's the other x value? 4/3. 4/3. So there are two x coordinates on this graph of f where the tangent slope can equal 0. Well, one of the technicalities of the mean value theorem is you cannot find a tangent slope at an endpoint. So the correct answer is 4/3.
Will you repeat that last?
So technically, we find slopes using the green formula sheet, right? But technically, how those slopes are found is by doing a secant to the right, secant to the left. So if you're at the end of a function like this, like the very end,
Oh yeah, you talked about that
you
yesterday.
can't go secant left. So the mean value theorem won't be satisfied in that point.
Wait, what was the statement you said you can't find?
So you can never satisfy the mean value theorem at an end point because you cannot find a tangent slope at an end point.
Actually, confused with how we determine x equals 0 and
So what does it mean to solve an equation? It's simple. It's all about the equal sign. Let's find the x and x is true. That's what solving. That's what equals 4. So what x will make this 0? So you put a 0 here. What would this be? What the frick? So it's a whole 0. Exactly the multiplier. So that works. But there's another x that also. If you put a 4/3 here, what's 3 times 4/3? 4. What's 4 minus 4? It's 0 times 4/3. Yeah, that's not what it's doing.
So how do we know which one to use?
The mean value theorem can't be satisfied at the end point. So x equals 0 is one of the ends.
Okay.
Please,
Okay, so I'm looking at this problem, and it says let f be the function given by f of x cubed minus 3x squared. What are all the values of c that satisfy the conclusion of the mean value theorem of the differential calculus on closed intervals 0 and 3? Then the answers are 0, only, 2, only, 3, only, 0 and 3, and 2 and 3. Couldn't you just automatically know it's 2 only because it can't be 0 or 3?
Yeah, that was an example of where the test writers, they didn't do a very good job. No,
Or
really.
they tried to get you to do more.
Something, because you're correct, they've given, every single answer includes an endpoint, except for one. So that's not likely to that, like what year is that going to
This is new for 2018.
be? No, look.
Oh, 1985.
There you go. So I feel like I can guarantee you they never did that again. Like they did it once, and oh shoot, that was a dumb question. They learned. Other questions here?